back to the lecture series in application of nanomaterials in agriculture. So, we are into the section where we are talking about the role of nanomaterial in animal production. So, if you remember in the last class, we talked about the mode of synthesis and how it affects the results or the desired results. In that process, I told you that while a whole new paradigm was getting birth in the University of Central Florida while working with cerium oxide nanoparticles, there were a couple of groups who showed that cerium oxide nanoparticle has inflammatory effect, and I told you that it is the synthesis, how we are doing it, it matters. So, one of the technique which was followed at that point I wanted to highlight. It's a very interesting technique, pretty straightforward though. So, you take your precursors. So, this will take you back to the very first lectures when we devoted time on the synthesis. So, now here is an application to say. So, what you do, you take the basically nonpolar solutions and the surfactants which are there. So, you use the surfactant molecule and some nonpolar solutions. You are using nonpolar because you are doing an aqueous, you are working on an aqueous system. So, you have the nonpolar solution, which is, let me represent it by, you have the nonpolar solution, and so let's represent the nonpolar solutions in red. And you have the surfactant molecules which are represented by green, and then you have the target, which is your cerium, what you wanted to make, and let's represent it by blue. Okay. Now, let me label them. So, you have the green, you have the surfactants, and if you remember, we talked about the surfactants to ensure that you are reducing the surface energy of the system, and then you have cerium salts, and this is all happening in an aqueous environment. So, in an aqueous environment, what will happen? There will be formation of the micelles. So, these nonpolar stuff, in order to reduce energy, they will form micelle like structure, micelle formation. So, the micelles will be most likely something like this, of the micelles forming. If you sonicate this thing, they will form micelles like this. Okay. It's a simple surface chemical process. You are doing a sonication here. Pretty uniform spherical shaped micelle, and it is in an aqueous environment. In order to reduce their surface energy, they are forming micelles, and these micelles are getting separated because you are using a wide array of surfactant molecules. Now, I am introducing the surfactant molecules. Okay. Now, in that process, what will happen is that a bunch of cerium molecule will get entrapped inside it, because their concentration is fairly higher. Okay. Now, now what you are seeing is that each one of these micelle is acting as a nanoreactor. So, if you analyze this, so you take this one, so you will be seeing the signature, chemical signature of, using XPS, extra photoelectron spectroscopy, chemical signature of cerium, surfactant, whatever surfactant molecule you are using, and non-polar solvent. Now, cerium, when you look at it, if you look at the XPS, you will see C3 plus, C4 plus, and this whole thing we are talking about a very, very low temperature and in the room condition where you are doing it. So, this is what I was trying to highlight, that whenever you are synthesizing these kind of particles, you should know that how you are getting there, because unless you are sure about the genesis, how this particle has been formed, it is really tough. Now, when you compare this, and if you look at their overall geometry, how they look like, if you take up any of these particles, this is that unique spherical shape and pretty soft. So, these are the whole area of soft matter, the synthesis, and that is why it is very, very important that you understand in completeness that the field, you have to understand synthesis, and that is why we spend so much time on synthesis. You have to do the characterization right, and then of course your testing. And whenever you get contradictory results, do not discard the results. You are very fortunate that there are results which may tell you how you are getting the material, what are the reasons why you are getting certain type of results. Always look at it very carefully, and this is what can be said so truly about ceria. As the field slowly emerging, there are things which are coming on surface which was never thought out at that time. Oh wow, this could be a problem. I mean, now if I go back to the previous slide, something like this, a sharp edged, rugged edged particle, instead of showing a positive effect, this will lead to some form of an inflammation, and that is what precisely it did. Now, that is the reason why I was telling in the very early, synthesis is now moving more towards biological synthesis, or in other words, we are now trying to emulate nature, how nature does stuff in small nanoreactors, how they do it. Now, from here, what we will do, we will move on to, after highlighting this part and kind of discussing lot of positive results and handful of negative results, and what possibly is the reason for it, we will move on to one of the very interesting aspects of exercise biology. So, all of you do exercise, right? Some have the ability to do heavy exercise, some can't do, they feel tired. Why we do feel tired? Why some can do heavy exercise? And this exercise biology has a lot of role in animal production. There are bullock carts where animal does the exercise. We have horse riding where the animal does exercise. We have series of them where exercise biology plays a critical role in animal production. But if you ask a physiologist about exercise and its benefits, pros and cons, you will have one of the most ambiguous answer. What has emerged over the year is something which may stun some of you, those who are not aware about exercise, is exercise is a kind of a double-edged sword, if to tell it very precisely. Exercise is a double-edged sword for skeletal muscle. Okay. Why is it a double-edged sword for skeletal muscle? Because small amount of ROS generated during mild exercise. So during exercise, it's generated ROS or reactive oxygen species. Okay. The small amount of ROS which is generated during exercise is delta amount of ROS generated during exercise is essential for force generation or skeletal muscle force generation. This is very critical, okay, and must, as a matter of fact. Whereas large quantity of RO is generated. Now here you are doing a mild exercise, okay. Suppose you are one of those who are doing very intense exercise. Now during intense exercise, large quantity of ROS is being generated. Large quantity of ROS. Okay. This large quantity of ROS which is generated during intense exercise may cause contractile dysfunction. Okay. Cause contractile dysfunction as well as it may cause muscle weakness and fatigue. Muscle weakness and fatigue. So if you see the same exercise which is essential for force generation when you are doing mild exercise, has a totally different scenario when we do intense exercise. And so say for example, a person has some kind of problems in hypothetical situation with SOD or GPX or catalase, the antioxidant enzyme. So you're realizing if you are generating reactive oxygen species, which is .OH, .O, .O, and all those kind of NO dot, NO double dot, series of those reactive oxygen species, these has to be scavenged by antioxidant. Unless they are being scavenged by antioxidant enzymes, we will have serious issues. And exercise biology, so those who work on horse production, those who, let's look where you need these kind of situation arises. Say for example, those who work on horses, those who work on chicken for meat, those who work on bulls, those who work on buffaloes, camels, where there is tremendous amount of, I'm just to name a few, I'm talking about. One second. Okay. So this is where there is huge amount of muscle movement involved. So whenever we talk about a lot of muscle movement, we are essentially talking about, especially in terms of skeletal muscle movement. So when you talk about, okay, let me just be a little bit more specific, skeletal muscle movement involved. And skeletal muscle is the key part of the muscle which is consumed for meat production. So skeletal muscle dysfunction due to high concentration of ROS may not be beneficial for the animal producers or for people who are training the horses for horse race or running, an equestrian series of them, from defense applications to sports. There is a whole range of areas where animals are needed. Now, under that situation, what they do? Now, if you look at it, when you talk about where all the animal stuff goes, I told you that there is a whole area of nutraceuticals. So much of these nutraceuticals, what you will observe, are small inorganic salt and plus lot of antioxidants which are being given. Now, does it make sense to you why you needed to supplement a huge amount of antioxidant into the diet of the animals? Because if you really want very good quality skeletal muscle growth, coming back here where I was, okay, if you really want very good quality skeletal muscle growth, you needed to have a lot of antioxidant. You needed to supplement them with antioxidant. The reason being, because whether they are doing mild exercise, mostly they do heavy exercise most of the time, moving around, whatever, they will be generating lot of reactive oxygen species. So now that is the reason why I take you there, because now I will take you back to this reaction which I started probably 3 or 4 classes back. Here is the reaction back. Here you have one very interesting molecule which has a pseudo infinite half-life in a very small concentration. Now, much of these diets, so there is another very interesting aspect. What I wanted to highlight here is, it has been observed that one of the critical questions which has been asked was, skeletal muscle physiology is, could antioxidant therapy improve skeletal muscle endurance? Okay, could antioxidant therapy improves endurance of skeletal muscle. A very, very critical question. And this is the aspects what I wanted to highlight now at what are the results and where we are heading. So, I will close in here. In the next class, we will talk about the antioxidant therapy and how it all affects skeletal muscle physiology. Thank you.